You're going to add your S plus your P of every sublevel will give you the valence electrons. Now, if you're in the D, that's going to be a little different, so remind me later, okay? Elijah, we need to be unplugged completely. Anytime during a lesson, we should be plugged in, okay? All right, so now pick an element, something that's either in the S or P section of your periodic table, to the formula. So you have 2 plus 4, what is that going to give you?
6.
Yep, that's how many valence electrons you have, okay? Now, why is this important? This valence number is also going to tell you how many electrons you have on the outside energy level, so you can do your bonding, which is going to be your next chapter. So sulfur is going to have 6 electrons, so you have 1, 2, 3, 4, 5, 6. This is your Lewis dot structure. Okay, we see that? Those are going to be the electrons that can bond or not bond if they're already paired. Now, anytime you have an element, you can't just have dots all the way around, okay? They have to have an order. You see how there's only 2 on each side? And here there's an empty space, and here there's an empty space, because this can bond with another element. And that's where your chemistry starts, your bonding, okay? The breaking and the bonds coming together and breaking apart is chemistry, okay? Are we okay so far? Okay, give me another element, anything. Potassium. Okay, so remember, this part is your S, this part is your S, and this part is your P. Sulfur. Okay, sulfur is right here. You know what? Let's make this a little bigger so we can see that. Okay, so sulfur is in that third period, right? You're in the third period, correct? Meha, we need to stop talking, please. Okay, and pay attention. You need to add your S's and your P's up until you get to that element. Okay, so I have 2 S's here, right? And then I have 1, 2, 3, 4 on your P. So let's go now. Let's go to the other frame, and here's your periodic table. Okay. And we're going to look for potassium. What section is potassium in? It's right here, right? It's in the 4th energy level. Now, you have to add your S plus your P's, but if you don't have a P, that's okay. How many S's do I have?
1.
Just 1. And I have 0 P's, so it's just 1. My valence is 1. That's it. So potassium has just that 1 dot. That's it. That's all there is to it. Okay? Let's do something like carbon. Go ahead.
Isn't the valence electrons what the groups are for?
Not necessarily. Not okay. Don't always go with that. Okay, that's a different thing. Okay. Yes, every single group is going to have the same valence. So, for example, we did sulfur already, right? If we do oxygen, you're going to have 1, 2, 3, 4, 5, 6. You're still going to have the same valence, right? Because the same group is going to have the same valence number. Okay? But let's say you're in the D section. You're not going to go by the groups, okay? Because also sometimes for the Lewis dot, you're going to go by the charge. So let's do something like iron. And let's go ahead and erase this. That's a good question, though. Okay, so iron is in the D section. So your S and your P's are always going to be filled, because remember this is row 3. So for period 3, your S's are 2, and your P's are always going to be 6, right? So that's always going to total what?
8.
Yep, the SNP is going to always total 8. So now, you can never have more than 8, because remember when we did the valence electron, you can have 2 on each side. 1, 2, 3, 4, 5, 6, 7, 8. You can never have more than 8, okay, to do your bonding. So now, we have the 8, but we're not finished because iron is in the D section. So we're going to start from the first one. 1, 2, 3, 4, 5, 6. So now 8 minus 6 is going to give me how many? 2. So my valence is going to equal 2. Can you see how your valence changes? Okay. Now, it does not necessarily mean that you're going to have 2 dots for your Lewis dot structure, because iron is a transitional element, right? Remember when you labeled your periodic table, this is your transitional metals?
Yes.
Okay? So, a lot of these have different charges. So iron, let's say you have a +2, or let's say you have a +3. Okay, so the charge is going to tell you how many dots you have. So if I have a +3, I have 1, 2, 3 dots. You see how that's different from the valence?
Yeah.
Yes? Okay, that's only going to happen when you're in the transitional metals. Okay? Yes? It's only going to happen when you're in this section. Or, you know, down here
So
too.
what if it has no charge? Then it's just 2.
If it doesn't have any charge, this middle section is going to have a charge.
Oh, always.
Yes. Okay, and for now, I'm going to give them to you. Later on, I'll show you how to figure those out. Yes? What was that question? You sure? Okay, so remember the sides. If it's on the S, if it's in the P, you're going to add up your S's plus your P's. But if it's in the D section, you're going to actually subtract. Okay? Let's do another one. And I want you to look at your own periodic table. That way you can tell me what to do. Okay, where is my periodic table? Do we have that out? Okay, so pick something. Pick something, anything.
What, an element?
Pick another element.
Uranium. How about that?
Okay, let's pick something that's on top.
Uranium.
Okay, let's not go too far down in the periodic table. We already did sulfur.
Oh, we did?
Neon.
Magnesium.
Okay, neon.
No.
What section is that in? The S, the P, it's in the P section. Neon is on the right side of the periodic table. Yes? Okay, so how many S's does it have? It has 2, right? Okay, and how many P's does it have? 6. So this is going to have a valence of 8.
Does it mean like it's not yet?
Because, now, why is it an inert gas? Because Ne has a valence number of 8. You have 1, 2, 3, 4, 5, 6, 7, 8. So does it need to bond with anybody? No. Remember that the whole objective of the element is to try to get a filled shell, which is all 8. Okay, it's trying to fill all of its little spots. Okay, that's a come if you have something like carbon. Look at carbon. What are my S plus P there?
2 and 2.
2 and 2. So you have a total of 4. So my valence is 4 for carbon. That means I have 1, 2, 3, 4 dots. So because I have 4 missing, these spaces here, this is why it can bond. Okay? That's why it can bond. All right, so if you have something like methane, I add hydrogen. How many dots does hydrogen have? What's your valence? 1. Very good. So it has 1 dot. So now hydrogen can actually bond all the way around. You can have 4 hydrogens, and that's why your chemical formula is CH4. for your compound.
What is that? What is that?
Your compound, just like water, H2O. That's a chemical formula. It's a compound.
You say what is that?
It's a
What does
substance.
CH4 make?
Methane.
Methane.
Okay.
Did not know that.
Let's do water. Let's do water. Okay.
It's like that.
We're figuring out the valence and then the Lewis dot structure. So this is the Lewis dot structure down here. Okay, right there. And this is my valence number. Okay. Do we need another example on how to get the valence? Do we need to do another one in the D section? A D section? Okay. Hydrogen, what's my valence for hydrogen? 1. So that means I have 1 dot, right? Oxygen, what's my valence for oxygen? 6. Very good. So 1, 2, 3, 4, 5, 6. Now I always put the dots away, that way you can bond easy. So now these two can bond. We see that? And now, is oxygen happy? It's using 7 of its dots. It needs to add 1 more, right? So you can put another hydrogen. And then you have another dot. Because that space is there, that's why you can bond here, and now that makes your water. You see that? So the importance of valence electrons in your Lewis dot structures is going to actually show you how you can bond certain elements together, okay? But the important thing right now is to know how to figure out the valence and how to figure out your Lewis dot. Okay, so are we okay with the valence? Yes.
So, like, when you put the dots down, in what order do we do it?
Oh, that's a good question. You don't have to actually put them in a certain order. But just like I did with carbon, because we had 4 valence for carbon, right? I always put 1 dot on each side before I actually do a second loop, okay? And here for oxygen, I put these dots on this side so it'd be easier to bond here. Now this is going to go with the molecular geometry, and you'll be able to see how those go together later, okay? Yes?
So it has one dot, you can like put it.
Anywhere. Yes. This part is bonding, but this part, so let's pick something like, okay, let's do gold. Gold is in the D section, and it's in the it's in the 5th period. So now, because you're in the D section, that means your S and your P is always going to equal how much? 8. Okay, so my S and P is 8. And how much is D? My gold. How many squares does it take to get to gold?
Is it always gonna be 8?
If you're in the D section, the S and P will always be 8, because if you look at the periodic table, here, let me put another picture of the periodic table.
Oh, right there. Oh, B7.
Okay.
Bigger.
Okay, let me show you why it's always 8. When you are to get to the D section, you have to pass the S and the P's. And your S's always have 2, and your P's always have 6. So 2 plus 6 is always 8. Okay? So now gold is down here. How many squares did it take to get to gold?
7-ish, I don't know. 6.
9.
It's 9. Very good. Guys, don't forget to count from the beginning part of the section. Okay? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So 9 minus 8. You never have a negative number here. Okay, so 9 minus 8 is 1. So my valence is 1. Okay? Now, because it's in the transitional metal, you have to look for the charge to figure out the Lewis dot, though. Okay? Yes? Okay, so your whole objective today is to figure out the valence number. By figuring out the valence, then you can figure out the Lewis dot, except for the D section. Yes, here you're going to write the electron dot diagram, which is your Lewis dot. But You know what? Where it says element, they forgot to put valence numbers. So they're like A for boron. How many valence would that have?
Would have
5.
Boron,
3.
it would have 3 because boron is right here. So 1, 2, 3. So your valence is 3. You're going to put that under the column where it has like A boron. Go ahead and write it in that square. Okay, we see that? Yes? So you can have the valence in front and the electron dot diagram at the end. Now don't forget the configuration and the orbital.
So
Yes.
for silicon, it would be valence equals 4, right?
Silicon, yep, your valence would be 4. Very good.
And
Okay.
you count the actual.
The squares, yeah, because you have 1, 2 in your S section, and then you have 3, 4 in your P section. So that totals 4. Okay, very good. Okay, anybody lost? What's the first thing you're going to find?
The valence electron.
The valence number. And then what's the second thing you're going to find?
The orbital filling.
The Lewis dot structure. Okay, what was that, Miha? Kristen?
Are we gonna be able to do
Yes, you can finish the cups from yesterday. Let me go ahead and pause.